So we're going to talk today primarily about carbonyl chemistry, of course, with aldehydes and ketones, and also with carboxylic acids and their derivatives. So I want to start by discussing some oxidation states that will help you when you're tracking the carbons or trying to keep track of the change that a carbon might undergo during a reaction mechanism or a synthesis problem. So, of course, an alcohol, such as a primary alcohol, here is in the +1 oxidation state, or that carbon has one bond to an electronegative atom. So the oxidation level, the way that I define it, or the oxidation state, is just counting up the number of bonds that a carbon shares with an electronegative atom. And that electronegative atom could be nitrogen, oxygen, chlorine, etc. It's not hydrogen or carbon. So alcohols are in a fairly low oxidation state. And to make an alcohol into a carbonyl, right, it has to be oxidized, or we have to remove one or more of the hydrogen atoms that are attached to that carbon there. So if we oxidize this primary alcohol with a weak oxidant like PCC,